Hello, I welcome you all to your own channel MSK Learning. Now in this video we will start the vector integral theorems, right? So there are the three theorems we have to learn in the vector integral theorems. So that is these three theorems are nothing but the Gauss Divergence Theorem, the second one is the Green Theorem, and the third one is the Stokes Theorem, right? So this theorem deals with the conversion of that is first one. You can see that first theorem means Gauss Divergence Theorem deals with the conversion of f dot n ds into a volume integral where s is a closed surface. So any function vector f is there, okay, and normal vector is n. So f dot n ds will convert into the volume, right? And second theorem, which is the Green Theorem, will deals with the conversion of f dot dr into a double integral over a region in a plane when c is a closed curve in the plane, right? And the third theorem, which is nothing but the Stokes theorem, which deals with the conversion of del of a, integral of del of a into n dot ds into a line integral around the boundary of an open two-sided surface, right? So first of all, we will see the first integral theorem is nothing but the Gauss Divergence Theorem, right? So the Gauss Divergence Theorem is what? Here we see that let S be a closed surface enclosing a volume V if f is a vector, is continuously differentiable vector point function, then we can say the integration of divergence dot f dot dv is equal to integration of f dot n dot ds, right? So where n is what? Where n is the outward drawn normal vector at any point of S, right? So first of all, we can say that we have to write down this LHS into the Cartesian system, right? So whenever we have to deal with the divergence theorem, right? So we have a Cartesian form of that equation is what? That here you can see the Cartesian form is nothing but let f is equal to f1i plus f2j plus f3k, and n is the cos alpha I plus cos beta j plus cos gamma k, right? Where cos alpha, cos beta and cos gamma are the direction cosine of n. Then you can say f dot n is equal to f1 cos alpha plus f2 cos beta and plus f3 cos gamma. Divergence of f you already know in the previous classes, that divergence of f, how you are finding that dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So the divergence theorem can be written, we can write this divergence theorem in a triple integral of dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z dx dy dz, right? That is equal to, in Cartesian form we have a we have written the divergence equation as what? That is divergence of f into dv. So divergence of f is nothing but this one, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, and v is what? Dx dy dz is the volume, right? That is equal to what? This is equal to integral of f dot n into ds. So in Cartesian form, f dot n you can write f1 cos alpha plus f2 cos beta plus f3 cos gamma into ds. ds is the surface, right? So you have this equation. Further you can write f1 dy dz plus f2 dz dx plus f3 dx dy, right? So this is what you have that Cartesian form of a divergence theorem, right? So we will see this with the help of the working example. So the simple example we will do first, and then we'll move to the some higher order type problems, right? So this problem is on the screen, that see, using the divergence theorem, evaluate integration of x dy dz plus y dz dx plus z dx dy, where s is the x square plus y square plus z square is equal to a square, right? Is it or not? Right. So now you can say from the we can use the divergence theorem, right? So here we go, that solution, that is solution, right? According to divergence theorem you can write, right, that is Gauss Divergence Theorem, right? So what is the Gauss Divergence Theorem? You have Gauss Divergence Theorem. So the Gauss Divergence Theorem is nothing but that is the integration of surface of f dot n into ds, right, is equal to divergence of f dot dv, right? F dot dv. So this is what you have, f dot n ds is equal to divergence of f dot dv, right? Now we can find that LHS of this side, this LHS f dot n is equal to what you can write, f dot ds you can write like in the Cartesian form you can write. So here we go again, just hold on for a sec. So this is what you have a, see this equation is there, that is divergence theorem we have written like that. Now you can write down the f dot means LHS of this Gauss divergence theorem in a Cartesian form, right? So here you can write again that LHS terms of Gauss divergence theorem, Gauss divergence theorem, right, in Cartesian form, right? So just now you have seen that how to write down the Cartesian form, right? So LHS of this term we can write in the Cartesian form, that is f1 dy dz. So integration of f1 dy dz plus f2 dz dx plus f2 dz dx plus f3 dx dy, f3 dx dy, is it or not? In the Cartesian form we have written. So this is your Cartesian form of f dot n into ds, right? Now what we will do, that you have to simply equate this, right? That is f1 is equal to what, that in your equation, that if you see this is the equation is given to you, that is this the equation is given, that is f1 dy dz, f2 dz dx, f3 dx dy. So f1 is equal to what, x, fy is equal to, f2 is equal to y, and f3 is equal to z, is it or not? So now you can write it here that on comparison, right, from the question, right, that is f1 is equal to x, f2 is equal to y, and f3 is equal to z, right? Now you can find out the divergence of f, right? So you can find that divergence of f is equal to what, that is dou f1 by dou x, right, plus dou f2 by dou y, sorry here it is a small letter I have written, it is capital only, dou f3 by dou z, right? So x differentiation with respect to x is what, f1 differentiation with respect to x is 1, so the in I j k also, so this is what you have, a 1 plus 1 plus 1, right? So it is what, 1 plus 1 plus 1 is equal to 3. So here you got that divergence of f is equal to 3. All right, okay, so that divergence of f we got. Now again you can say that from the Gauss divergence theorem is what, that is integration of divergence of f into dv, right, is equal to what you can write, is equal to, you can write divergence of f is what, 3 into dv, right, and the volume we have this is the volume, right? So dv integration is what, v, so this you can got, that is this is equal to how much, that is 3v, right, and the v is what, volume of the sphere with the radius a. So where you can say, where v is the volume of a sphere with radius a, right, with radius a. So what is the volume of the sphere? You know the volume of the sphere is nothing but the 4 by 3 pi r cube. So pi r is what, a cube, right? And here again you can say this is what, so divergence of, here we go, that divergence of f dot dv is equal to what, that is integration of 3 dv, right, which is equal to 3v, right? So that is equal to 3, and v is equal to what, you can write 4 by 3 pi r cube, so 4 by 3 pi a cube, so 3 get cancelled. So here your answer is, that is divergence of f dot dv is equal to 4 pi a cube, right? So this is how you will find out the solution with the vector integral or integration theorem. Thank you.